Hello everyone. This presentation explains the step-by-step procedure of IS method of concrete mix design. Mix design, it is the process of selecting suitable ingredients of the concrete such as cement, aggregates, water and admixtures and determining their relative proportions to produce concrete with required strength, workability and durability with economy. And in India, mixed design we are carrying out using IS recommendation of IS 10262 and exposure and durability provisions of IS 456. There are two approaches to be followed in the mix design. In the case of nominal mix, it is suitable for ordinary works up to M20. And design mix is suitable for all higher grades and quality controlled works. These are the code references we are following for concrete mix design. IS 10262-2019 gives the concrete mix proportioning guidelines. IS 456-2000 is a code of practice book for plain and reinforced concrete. And IS 383-2016 gives a specification about the coarse and fine aggregates used in concrete. IS 269 and IS 1489 is giving specification for OPC and PPC cement. IS 2386 details about the test methodologies to be followed for aggregates used in concrete. SP 23/1982 is a handbook on concrete mixes. Concrete mix design is a systematic procedure used to determine the proportions of ingredients of concrete. The mix design process consists of some important 8 steps. Step number 1 is design stipulations. The first step is collecting all the design requirements. We must decide the grade of concrete such as M25 or M30, type of cement, OPC or PPC, maximum size of the aggregate 10 mm, 20 mm or 40 mm, exposure conditions mild, moderate, extreme, severe and the required workability based on slump value, method of placing manual, vibration or by pumping and degree of quality control and the type and grading of aggregates. These parameters act as the foundation for the entire mix design process. So next is about calculating the target mean strength. Concrete is not designed exactly for the characteristic strength because variations occur during production. Therefore, IS 10262 recommends using the formula target mean strength F-CK is equal to characteristic compressive strength FCK plus 1.65 into S. S is standard deviation. And the table below gives the assumed standard deviation values for different grades of concrete. For example, for M25 grade concrete, the target mean strength becomes 31.6 megapascal using the equation, and here the standard deviation is 4 megapascal. This ensures that almost all concrete produced at the site achieves at least the specified characteristic strength. The next step is selecting suitable water cement ratio. The ratio is obtained from the strength relationship curves and then checked against the durability limits specified in IS 456. So the chart given here gives the water cement ratio to be selected for various grades of concrete. The lower value between the strength requirement and durability requirement is always selected. For severe exposure conditions, lower water cement ratios are required to improve workability. So next step is selection of water content. After fixing the water cement ratio, we determine the water content. IS 10262 provides recommended water content based on the size of the aggregate, maximum size of the aggregate. For 20 mm aggregate, the basic water content is 186 kg per cubic meter. If higher slump is required for pumping or easy placement, the water content is adjusted accordingly. The use of superplasticizers can reduce the water requirement while maintaining the desired workability. So next step is calculation of cement content. It is calculated using a simple equation, cement content equal to water content divided by water cement ratio. The calculated cement content must satisfy the minimum cement content specified in IS 456 for the particular exposure condition. It should not exceed 450 kg per cubic meter, which is the recommended maximum limit to control shrinkage and heat of hydration. So next step is estimation of aggregate proportion, estimating the quantities of fine and coarse aggregates. IS 10262 provides tables for selecting the volume of coarse aggregate depending on the maximum aggregate size and grading zone of fine aggregate. If the water cement ratio changes, small adjustments are made to the aggregate proportions. This step ensures a well graded concrete mix with good workability and strength. Next, mix calculations. Now the actual mix proportions are calculated using absolute volume method. In this method, total volume of the concrete is equal to the combined absolute volume of cement, water, aggregates, admixtures and entrapped air. This calculation finally gives the quantities of each material required for 1 cubic meter of cement, concrete. Next is trial mixes. Finally, the calculated proportions are not directly used in construction. IS 10262 requires trial mixes to verify both strength and workability. Normally, 3 trial mixes are prepared with slight variations in the water cement ratio. If the concrete is too stiff, too workable, or fails to achieve the required strength, suitable adjustments are made until the desired performance is attained. To summarize, the IS method of concrete mix design is a logical and scientific procedure. It starts with collecting design requirements, calculating target mean strength, selects the water cement ratio, determines water and cement content, estimates aggregate proportions, performs absolute volume calculations, and finally confirms the mix through trial batches. By following IS 10262 2019 together with IS 456 2000, we can produce concrete that is strong, durable, workable, and economical. Thank you.